of Allah, the most merciful and most beneficent. It's our lecture 6 in the track of applied mathematics, and today our main goal is to discuss some special types of functions like the gamma function and the beta function and some of its properties. And the next thing that special functions, and then we'll be discussing some transforms. The first thing that would be a Laplace transform, and if we spare time today, then we'll be going ahead with some other transforms. So gamma function and beta function are very useful in the course of applied mathematics, especially they are used in transforms, solving differential equations, and these are very often used in mathematical physics as well. We'll not be doing mathematical physics on some advanced level, but this is what we call the fundamentals of mathematical physics. So let us define what do we mean by the first special function, what do we call the gamma function. So the first thing that we need to discuss is the gamma function, also called the Euler's integral of, I think it is called the Euler's integral of second kind, and the beta function is called Euler's integral of first kind, because these were basically introduced by Euler. So Euler's integral of second kind, or simply we can call Euler's second integral, and the beta function is Euler's integral of first kind. So if we take this particular function, this is basically the generalization of factorial function, if we see. So we know very well what we mean by n factorial. So n factorial is basically defined as n times n minus 1, n minus 2, up to, let's say, the last natural number, that is 1. And this is defined for n is equal to 1, 2, 3 and so on. And when specifically n is equal to 0, it means 0 factorial is equal to 1. This is the exception for that. Now we can also find this n factorial with the help of an integral. So n factorial is simply integral from 0 to infinity e power minus t and t power n dt. So if we evaluate this particular integral, then we can also find out the values of different factorials. It means, for example, for 0 you want 0 factorial. So you just put here 0, t power 0 is 1. So this is integral 0 to infinity e power minus t dt, and when you solve this, your answer is going to be 1. So we can also rewrite this factorial function into this integral form, and we know very well how to evaluate the factorials of different natural numbers. It means factorial of 3, 4, 5 and so on. So can you tell me what is going to be the factorial of n minus 1 with the help of this same integral? You know very well this is going to be 0 to infinity e power minus t power. This is n factorial, the power is n. This is n minus 1, the power is n minus 1 dt. And this particular thing is what we call the gamma function of n. So this is capital gamma from the Greek alphabet, and you know very well the small gamma is going to be something like this. This is capital gamma and this is small gamma. So capital gamma of n is what we call the gamma function of n, and it is defined in this way, which is simply equal to n minus 1 factorial. So this is what we call the definition of gamma function. That is integral 0 to infinity e power minus t and t power n minus 1 dt. Okay, so now the thing is that in this particular integral, this t is called dummy variable. It means you can replace this t with any variable. This is variable of integration. You can convert it into u, convert it into x or z, it doesn't make any difference. But specifically, if we are able to evaluate factorials, then why we are going to define gamma function? You can evaluate 3 factorial, you can evaluate 4 factorial, you can evaluate any factorial for these numbers. But gamma function is what we call the generalized factorial. It means if I ask you what is this, what is the factorial of 1/2, this is the big question. But we can evaluate this factorial with the help of this integral. Okay, and this factorial will simply be gamma function of some value, whatever it is. So one thing is that gamma function of n is defined as 0 to infinity e power minus t and t power n minus 1 dt, and here it is defined for, let's say, natural numbers. But you can also define this particular thing for all the x values. Let's say x belongs to some positive real numbers. You can define gamma function. So for that we generally write gamma of x is equal to 0 to infinity e power minus x power n minus 1 dx. Oh no? Is it okay? Or there's a problem? So I should change n into x. I should not change t into x. So e power minus t, t power x minus 1 and dt. It means now it is defined for natural numbers, this particular integral. And you can say when it is defined for all the positive real numbers, you can change n into x. So n can also be a real number. This is just a notation. It has no issue with this thing. Now, if I want to generalize this particular idea, I can also define it for a set of complex numbers. Then in some notations you will get this thing as well. Gamma of z is integral 0 to infinity and e power minus t power z minus 1 and dt. But it is not defined for all the complex numbers. There are some restrictions. We will see that it is not defined for 0, it is not defined for -1, -2, -3 and so on. It is not defined for these values. We will see later on why and how. Okay, so with the help of these particular definitions, either we are using gamma of n or gamma of x or gamma of z, we can deduce so many good properties of gamma function. And this thing is mostly asked in so many exams. So let us go ahead with some properties of gamma function.
सर यहाँ पे जो ये x या जो है z है, these are also constant numbers.
Yes. This n, x or z, these are some numbers. But when you write n, there is something generally comes in your mind that this is defined for natural numbers. But it is also defined for all x to be in the set of positive reals. Then you can also say that okay, it is valid for all the complex numbers, only these numbers are excluded from the list. So this is the most general form of gamma function, and this thing is mostly studied in advanced complex analysis courses.
Okay, sir, this definition is the definition of n minus 1 factorial.
This is a definition of n minus 1 factorial. This is. It means we can say that gamma of n is equal to n minus 1 factorial.
Whenever you variable variance and x real number when a variable change so the n x change so that
No, you can keep n same. You say that this n is a real number. It's just a notation. But when you read any book, you find n, you will just think that it's a natural number.
अच्छा सर, एक और बात जो यहाँ पे समझ में आ रही थी मुझे, तो ये थी कि जब हम कॉम्प्लेक्स नंबर्स लेंगे तो आयोटा इज अ वेरिएबल,
Yes.
तो उसको हम किस तरह से
Iota is a variable.
आयोटा इज अ इमेजिनरी नंबर,
It's fixed number.
fixed number,
Yes.
we can say
Yes.
that we can consider as a fixed number or
Fixed number. Fixed number. Because the problem is when this z is a complex number, that is x plus iota y.
okay.
You know very well this t or this z, they are complex.
Okay.
Now what happens that when you have some number raised to iota,
Okay.
it is basically an what we call a periodic function.
Period.
So the main behavior comes from the real part. There is no any behavior from the imaginary part. It means we say that this particular gamma function is convergent or it exists when this particular integral exists.
Okay.
And this particular integral exists in these cases. Otherwise it does not exist. So only we have to see that whether this integral exists or it does not exist. This is the main issue.
So what is the main reason to develop these type of special functions?
This is the good thing. These are basically formulated in such a way to solve so many complicated integrals and solve some sort of differential equations. Because when you solve a differential equation, you integrate. And when you are stuck in integration, you should have developed some good tools to deal with so many nasty kind of integrals. This is the main reason behind these things. Even we have so many integrals involving sine and cos, we can evaluate with the help of beta function. Otherwise we can't. So there is a relationship between beta and gamma function as well. So we will be developing these things today. Okay, so this is what we mean by factorial function, and this is what we mean by gamma function. Okay, now one thing that we can see is this thing is defined as integral 0 to infinity e power minus t, t power z minus 1 and dt. Can we evaluate or simply solve this integral with the help of integration by parts? Okay, can I write this thing? Gamma of z plus 1 is equal to 0 to infinity e power minus t, t power z dt. Just I am replacing z by z plus 1. Then this z would be z plus 1 and this z would be z plus 1. Plus 1 minus 1 gets cancelled and we get simply z. So we can do this. Can we solve this with the help of integration by parts?
Sure.
What should be my u and what should be my v?
Inverse exponential.
So my u should be
Algebraic, I think t power z.
t power z. So u prime would be z t power z minus 1. Okay? And my v is going to be e power t, e power minus t, and my integral of v is going to be minus e power minus t. We do these things now when we integrate by parts.
Yes.
So this is my u and this is my v. So the integral would be u same. What is u? E power z, and integral of v, what is that? Minus e raised to minus t minus integral
Yes.
derivation of u, and integral of v is minus e power minus t dt, and my limit of integration is 0 to infinity, 0 to infinity. So what is going to be this particular thing? Minus t power z e power minus t. I have to evaluate, let's say,
T minus
I can write this thing as minus t power z over e power t, and these limits are for
0 to infinity.
these limits are for t. Okay, when I apply t equals infinity, basically this has no sense. I have to just put here t first, then I have to apply a limit t goes to infinity. Otherwise this notation has no sense. And let me tell you this thing clearly. But we are simply doing it. So infinity here, infinity here. This is simply becoming infinity by infinity. What is it going to be? Indeterminate form. But let me tell you one thing. This is polynomial in t. This is exponential in t. The growth of this function is very faster than this.
Polynomial.
So simply this is going to be something divided by infinity, that is going to be 0.
Right.
Okay. And plus, because minus minus becomes plus, when I put t is equal to 0, this thing becomes 0. So I can simply cancel out this thing. So this thing becomes 0. Okay, then I am left with minus into minus
Positive plus.
plus, and I can take the z out. Why? Because this integral is in t. So this z is simply a constant. So now I have 0 to infinity e power minus t and t power z minus 1 dt, and I can write it z, and I can say that this particular thing is what we call gamma of z. So I have a formula, gamma of z plus 1 is equal to z times gamma of, and this is what we call the recurrence relation. Recurrence relation of of gamma function. Are you okay with this? Because this is the definition of gamma of z, we have already written. And this z is out, so I can write this z. This is gamma of z, so I have this formula. And we call this recurrence relation. Is it okay?
What does mean by recurrence?
Recurrence relation, it means the next value can be written in some expression of the previous value. It means you can find out next value in a sequence by using previous value multiplied by divided by something. This is what we call the recurrence relation. Or you can find out the next value by using, let's say, two previous values. And this is what we call the general term for Fibonacci sequence. You know very well. You take two previous terms, add them, you get the next term. So this is what we call the recurrence relation. And in most of the sequences, we don't get exact general term. We get a recurrence relation. So this is simply that thing.
Can we write this one z plus 1 factorial?
Yes, we can write. But we are going to avoid factorials. We are going to write something in the form of gamma function. Okay, already decided what is gamma of, gamma of 0 is not defined. We know very well. Because I told you that this is not valid for z to be 0 or minus 1 or minus 2 and so on. It means gamma function is not defined for 0 and all the negative integers. It is not defined for these values. Okay. Why this gamma of 0 is not defined? Can you tell me the reason? Gamma of 0 means I put here 0. This is going to be 0. So t power minus 1. E raised to minus t power minus 1, when you evaluate this integral, this diverges. That's the problem. So gamma of 0 is not defined for now. It means this particular thing z inside this should not be 0. Now what is gamma of 1? Gamma of 1 is going to be 0 to infinity e power minus t and t power 1 minus 1 dt. Am I okay up to here? Yes, I am putting z equals 1. So t, 1 minus 1 0, so this is simply cancelled. 0 to infinity e power minus t dt, and the integral would be minus e power minus t with the limit 0 to infinity. If I apply upper limit,
0.
minus e raised to minus infinity is going to be 0, and minus into minus plus e raised to 0 is going to be 1, so my answer is 1. So gamma of 1 is going to be 1. What is gamma of 2?
2 minus 1.
Can I write gamma of 2 in the form of this formula? So if z is equal to 1, so this is going to be 1 times gamma of 1. So you can write gamma of 2 into this form, 1 times gamma of 1. So this is going to be 1 times gamma of 1 is 1, so 1 times 1 is 2. What is gamma of 3? You can write what is 1 previous term.
1 times 1 is 1.
Gamma of 1 is 1, so 1 times 1 is 1, yes, 1 times 1 is 1. Gamma of 3 is 2 times gamma of 2. you have to go one term previous. This is z plus 1, this is z. So what is gamma of 2? Gamma of 2 is 1, so 1 times 2 is 2. So similarly, what is gamma of 4? That is 3 times gamma of 3. So you have to go just one term back to this. You have to just reduce one term. Gamma of 3 is 2, so 2 times 3 is 6. And we can say this is equal to 0 factorial, this is equal to 1 factorial, this is equal to 2 factorial, this is equal to 3 factorial. So you can say that gamma of n plus 1 is simply n factorial. Gamma of n plus 1 is n factorial when n is a natural number. We'll be discussing some formulas. This is one of the formula that we are supposed to keep in our mind. Any question up to here? Or it is okay?
So who are the men who give this relation
Which relation?
in our class? Who?
Fibonacci. Maybe it's the name of a mathematician, but I don't know. This is called Fibonacci sequence. I think it's the name of a mathematician. But these were introduced by Euler. This is called Euler's second integral, and beta function is called Euler's first integral. Okay, one thing that we already discussed, when you put this z is equal to 0, this is not valid. We know that thing. Now we knew one thing else, that gamma of z is also equal to, from this. Is it okay? Just I am taking this z here, and gamma of z is equal to gamma of z plus 1 is equal divided by z. We know very well this is not valid for z is equal to 0. And you can see this thing from here. When I put z is equal to 0, it is going to be undefined. Similarly, we know very well z is not equal to 0 now here. Then what can I not put here? I cannot put z plus 1 is equal to 0 as well. I cannot make this quantity as 0 as well. It means I cannot put z is equal to minus 1 as well. So I got simply two values for which this gamma function is not defined. We can say that these are the poles of gamma function. So we can extend this notion and we will say that gamma function will not be defined for these all the values. We can extend this notion in this way.
Sir, but when we see that in the numerator, we are here with the 0.
Yes.
This can be defined.
So this argument of gamma function should not be 0. One thing is that. If this thing is not 0, it means z should not be minus 1. And why it is not defined for 0, you can see when I put 0 here, it's a problematic situation. So you can extend this notion and you can generalize that this is not valid for these all the values. Gamma function is not valid for these all. You can extend from here. And how can you do this? Again, you apply the formula here. Gamma of z plus 1 would be equal to gamma of z plus 2 divided by z plus 1. You can apply formula here, the previous formula, and then you can write gamma of z into this form. And you can see now this is not valid for z equals 0, z equals minus 1 and z equals minus 2. And similarly you can extend this notion and you will generalize that when gamma function is not okay, when it is not defined. So are you okay up to here? If there is any question? There are some alternate forms of gamma function as well. We should at least know these things. That sometimes when the things appear, we can identify that okay, this is gamma function or this is not a gamma function. What if in this particular integral I put t is equal to y square? You know very well you can transform. a function from one set of variables to another set of variables by applying some sort of good transformation. In this one I am going to put t equals y square. What is going to be dt? 2y dy. So my gamma of z would be integral, limit is going to be 0 to infinity or something else. When I put t is equal to 0, y becomes 0, obviously. When I put t equals infinity, y becomes infinity. So it's not a problem. Just e power, now this becomes e power, because now t becomes y square, and this becomes t y square z minus 1, and dt is going to be 2y dy. So this becomes 2 integral 0 to infinity e power minus y square, because 2 is out, e power minus y square same. This becomes y power 2z minus 2, 2z minus 2 plus 1 dy. So I can write this 0 to infinity y power 2z minus 1 e power minus y square dy, and this is also another form of gamma function. It means you can call this as gamma function as well. Now what is the difference? The main difference is the power of e is a linear function here, and the power of e is here a quadratic function. This is the problem. You can call this one as gamma function. And we can evaluate these types of integrals as well in so many situations. Okay, how about when you put e power minus t equals y? It means you substitute this quantity equals y. Then you will see that when you apply this transformation, your gamma function becomes, I'm going to just write because you can transform by yourself. Now the limit becomes 0 to 1, and you will see that y limit becomes 0 to 1 as well. Log of 1 over y power z minus 1 dy. This is another form of gamma function.
एडवांटेजेस क्या है?
Advantages, when you find any integral which looks like this, okay, you see, okay, this integral looks like this, you will apply simply the gamma function. This is the advantage. Sometimes in exponential you get minus t, like minus x, minus z or whatever. Sometimes in exponential you get minus x square, minus z square. You can evaluate those integrals with the help of this gamma function. This is the advantage, otherwise there is no need. And this looks like when you remove this thing, 0 to infinity e power minus y square dy, this looks like Gaussian integral. And this is very useful in, I think, PDF of normal distribution. So this is the advantage. You can evaluate lots of integrals with the help of these formulas. There is a formula which is what we call the reflection formula, and its proof is very nasty, and it can be done with the help of complex analysis, but we are simply writing the formula. So the formula is gamma of z times gamma of 1 minus z equals pi over sine pi z. Pi over sine pi z. So it means the beautiful thing about this formula is you can rewrite the product of gamma function into a trigonometric function. This is the main thing about this. And you can check that whether this is valid or not. You can check this thing as well. Okay, let's put this z equals, when it is not valid. Okay, let me write. I think it is not valid for integers. It is not valid for integers, because when you put any integer here, if z is equal to 1 or 2 or 3, then sine 1 pi, 2 pi, 3 pi, 4 pi is going to be 0, and something divided by 0 is going to be undefined. So this is a formula which is not valid for integers.
So it does not belong to the.
Oh, sorry. It does not belong to integers. It means it is any value but not an integer.